Good morning to all of you. Myself Surya Chandan Sahu, part-time guest faculty in Department of Electrical Engineering, Bhuvanananda Orissa School of Engineering, Cuttack. In the previous class, we have discussed about domestic installation, and today we will discuss about how the electrical energy comes to the domestic installation, that is from substation to the point of the consumer. So, two types of installation is there. One is LT installation, that is if estimation for materials required for LT lines, that is low tension line. So, what is low tension lines? That means if the voltage is between, if the voltage is between 440 volt, that is known as LT distribution, and above 11 kV and more is known as HT line, that is high tension line. So, first if we will have maximum voltage up to 400 volt or 440 volt, then we will have LT line or low tension line. So, for low tension we have to first know what is number of spans. Number of spans means, suppose here is the substation, suppose here is the substation and we are moving from substation to the final consumer, here the final consumer. So, from this point to this point, this total is known as total length of the distribution line. So, from this between any two tower, this is known as span, between two consecutive tower, that is known as span. This is known as span, that is number of span is equal to length of line divided by span. So, number of spans will be how much? Total length of line, total length of line divided by span, one span means one span. So, it will be your number of span. So, span, what is, we can say also span means horizontal distance. This is your horizontal distance between two poles, each called, between two consecutive poles is called span. Suppose we are having 1000 kilometer line, and for 1000, suppose 100 meter between two consecutive pole is 100 meter. So, 1000 divided by 100, 1000 meter divided by 100 meter, this will give you 10. Number of spans is equals to 10. So, number of supports, next comes number of supports. So, number of supports is equal to number of span plus 1. That means number of span 10. So, total number of supports will be total number of supports is equals to number of spans plus 1. Number of spans plus 1. Number of span is 10 plus 1, that is equal to 11. So, total 11 number of supports is required for this LT line. So, next, number of RCC poles. RCC, what is RCC? Next, what is RCC? RCC is nothing but reinforced cement concrete. Reinforced cement concrete, reinforced cement concrete. So this RCC poles is very strong pole that is used at starting. This is used as this is your number of RCC poles, that is RCC poles is the starting or deviation points or anchoring points, starting points or deviation points. That means from the starting of the substation, that is your RCC pole is used from starting point, and anchoring point. Anchoring points means where suppose from distribution line from starting from substation to last end consumer, some poles there is repair is required, some that poles are known as anchoring poles. So that anchoring poles and deviation where there is a turning point, so that deviation point, these are must be RCC poles, that is reinforced cement concrete. And after that the other poles are PCC poles, that is plain cement concrete. PCC poles are PCC, that is plain cement concrete. Others are plain cement concrete poles. Next, number of cross arms. So number of cross arms, that is your 4 pin cross arms, that will be number of supports for one tapping pole. So cross arm means this is known as cross arm. So this is known as cross arms. These cross arms are used to support the conductor. So these cross arms may be V shaped, may be U shaped, or may be horizontal. This is horizontal structure. This is your horizontal. This is your horizontal structure. Some cross arms are U shaped. Some cross arms are U shaped. Suppose some cross arms are U shaped and some cross arms are V shaped. V shaped cross arm. This is your U shaped cross arm, and these are V shaped cross arms. These are V shaped cross arms. So number of supports is equals to number of cross arms. So number of supports here coming 11. So number of cross arms will also be here 11. So number of pin insulator. Next we will go for number of pin insulator. So 4 pin insulators are used plus number of supports. The formula is number of 4 into number of pin insulator is number of pin insulator, number of pin, number of pin insulators, number of pin insulators is equals to 4 into number of supports, 4 into number of supports, 4 into number of supports plus number of deviations plus number of deviations, number of deviations minus 1 dead end plus 1 anchoring point minus 1 dead end plus 1 anchoring point. Number of supports, here suppose number of supports is 11, suppose number of deviations, so number of deviations plus only one turning is there, one deviation, so one dead end and one anchoring point. So pin insulators are not used in dead ends and anchoring points. So dead end and anchoring points, suppose one dead end and one anchoring point. So total will be your 11 plus 1, that is 12, 12 minus 2, 12 minus 2 is 10 into 4. So 4 into 10, that is equal to 40 numbers of pin insulators will be required. It is an example of how many numbers of pin insulators are required. Next, number of strain insulators. So strain insulators, what is the formula? So number of strain insulators required. Number of strain insulators required is equals to 2 into 1 for each dead end, 2 into 1 for each dead end, 2 into 1 for each dead end, plus 2 into number of anchoring points, plus 2 into number of anchoring points, 2 into number of anchoring points. So here 2 into 1 for each dead end. So 2 into each dead end. Suppose one dead end is there and 2 number of anchoring points, plus 2 into 1 anchoring points. So it will be how much number of strain insulators? So it will be 2 into 1, 2 into 1, that is 4. 4 number of strain insulators are required. Next, number of length of conductors required. Next, we will go for number of conductors. So for this LT connection we will require SCSR number 2 conductor. So for this we require SCSR number 2 conductor. This is the specification of the cable. Conductor has required 3 into length of the line, that is equals to 3 into length of line, 3 into length of line. So length of line here is 1000, 3 stands for RYB, 3 for RYB, 3 phases. Length of conductor is 1000, so total is 3000 meter. And sag is suppose is taken 2% sag. So 2% sag if taken, so 2% sag is taken, so it will be 3000 into 0.02, so it will be 60 meter. So total length of conductor required is 3000 plus 60 equal to 3060 meter. This is for RYB phases. Next we will go for the length of neutral conductor. So neutral conductor required is neutral conductor specification is SCSR number 4 conductor. SCSR number 4 conductor is required, and for 1000 length is equals to 1000 meter, and we are having 2% sag, so is equals to 0.02 into 1000, that is equals to 20 meter. So total length of neutral conductor required is equals to 1000 plus 20, that is equals to 1020 meter. So this is our requirement of number of conductors. Next, number of gauge sets. So what is gauge sets? Gauge sets is, suppose this is your transmission line. So this is your supporting structure. And this supporting structure is known as gauge sets. So this gauge sets is your so your number of gauge sets required is number of gauge sets, that is the formula 2 into 1 for each dead end, 2 into 1 for each dead end plus anchoring point plus 2 into anchoring point plus 2 into anchoring point plus 2 into anchoring point plus deviation point आमर जो जगह डेविएशन रोचे से आमर गेज सेट्स दरकार एंकरिंग पॉइंट जो आमर पोल रिपेयरिंग दरकार से आमर गेज सेट्स दरकार प्लस डेड एंड रे आमर गेज सेट्स दरकार. So suppose one dead end, one anchoring point, one deviation point. So this is will be is equals to 2 into 1 plus 2 into 1 plus 1, that is equals to 5 numbers of gauge sets required. 5 gauge sets are required. 5 gauge sets required. Next, whenever guarding is to be provided, there is guarding. Suppose this is your road. Suppose this is your road. So here at the other side of the road, that is another tower. So here guarding is required. So for safety purpose we are using guard wires. So this guarding is to be provided and this guarding is provided at road crossing, canal crossing. So where it is provided? road crossing, canal crossing, canal crossing, road crossing, canal crossing, railway crossing, railway crossing, etc. So all these cases we use guard wires. So these guard wires are of 15 kg 8 SWG GI wire requires. For this purpose 15 SWG. What is SWG? Standard wire gauge. 15 SWG, 15 kg, 8 SWG, 15 kg, that is 15 kg, that is 8 SWG, that is 8 SWG, 8 SWG, 8 SWG, 15 kg, 15 kg 8 SWG GI wire. What is GI wire? GI is galvanized wire. This is the specification of guard wire for use in road crossing, railway crossing and canal crossing. Next, these are the materials required for installation of a LT line. So we can also do one problem relating to this concept. So problem is like this: a 3-phase 4-wire 415 by 230 volt LT line has to be extended for a length of 1 kilometer for electrification of a factory, assuming an average span of 60 meter. Here span is given 60 meters. Prepare the list of materials required for the same. So what are the materials required for installation of this